Hi everyone, how's it going? Welcome. Good to see you all here again. Let's get started, huh? So we're at lesson 4 of the Mathspace Academy. This is our 4th week, and today we're going to be continuing the work that we started last week on algebra. Okay. So before we get started, how's everyone feeling today? Now, we can't annotate on the screen. We learned that the hard way last week, but you can tell me in the chat box. So you can just describe the emoticon that best describes you right now. You might be sleepy or smiley or excited or sad or scared or angry or nauseous or just feeling great. So yeah, you can use some of the emoticons. That's great. I can see some cool sunglasses. I can see some happy smiles. Someone is content. Excellent. Good. Great to see everyone's excited and happy to be here. That's good. Must mean I'm doing something right. Good. Before we keep going, why doesn't everyone just say whereabouts they are in Australia? So I don't need the exact suburb, but maybe what's your closest capital city? So my closest capital city is Melbourne. I'm in Victoria. Okay, great. Yeah, we've got a mix of some people. We've got Brisbane, we've got Sydney, there's Canberra. Okay, cool. We're all East Coast people by the sounds of it. I guess in Western Australia, it's 10 a.m. at the moment. No, 8 a.m., sorry. So I guess they might not be awake yet, or maybe they're getting ready for school. Okay, cool. Well, East Coast Australia, represent. Great to see you all. Okay. So by now you probably know who I am, so I don't really need to go through this. So I work at Mathspace and I'm a teacher. And so I am your teacher for the Year 9 in Mathspace Academy. Just a bit of the housekeeping, we should go through this. Remember, these sessions are being recorded, so you can watch these later. So if your internet dropped out, for example, and you need to watch this at another time, you could watch the recording. They usually become available after 24 hours. And so you might be watching this from home as a recording. If you are, welcome. We're following the Mathspace curriculum. That doesn't really mean much if you don't use Mathspace. I just use the Mathspace textbook as a way to teach the content in Year 9. Okay. I will be asking questions today, just like I did last week. I think that worked really well. And so what I'm going to do now is I'm just going to make it so that everyone can only chat with me rather than each other. Okay, I'll give you a couple more minutes just to say hi to one another and you can chat to one another. But for the rest of the presentation, just because it's only me here, it's a bit hard for me to monitor the chat box. So yeah, we'll just have you guys chatting to me for the rest of the presentation. And there is a Q&A box. Okay, so you guys, I think a lot of you have been here previous weeks, so you know that there's this Q&A button that you can press where you can ask me questions. And at the end of the presentation, so, you know, around about 10 to 11, no, 10:50 a.m., there'll be about 10 minutes there at the end where I can ask any questions. So it could be about something that you're working on at school at the moment. It doesn't have to be algebra. You could ask me something else if you like about another maths topic. But yeah, I'll give you 10 minutes at the end there. Great, so we're going to get stuck into the next lesson. So this lesson, what we're doing today is we're doing binomial expansion, and also solving linear equations. And that's what we're going to be doing this week. Next week, we will be continuing this work. So we're going to be factorizing. So today, and what we did last week as well with the distributive law, it's all about expanding and simplifying expressions. What we'll be doing next week is the opposite, taking an expanded expression and then factorizing it. But yeah, we'll worry about that next week. As usual, I'll just let you know about what we have. This is available on YouTube as well as the Mathspace website. So Eddie Wu being that famous Australian maths teacher. So you could go in and watch some of his videos, especially if you're not up to this in school yet. So if you're in Year 9 and you haven't done binomial expansion with your teacher, might be worth you if you've got some time, if you don't have too much homework at school, you could watch some of these videos, and that way, if there's anything from today that you don't understand, you can go watch those videos and hopefully it'll make some more sense. Okay, because remember, this is a summary. This is a 1 week recap of like a week's worth of work that you would do at school. And those videos are available on YouTube as well, but going to wootube.mathspace.co, these videos will be mapped to those lessons in your Mathspace textbook. So let's get started. So this is the distributive law, okay? And so we covered this last week. So when you have a number and you multiply it by a sum, what you're doing is you're multiplying both terms in the sum, okay? So that A times B, and then you'll add A times C. And so you're adding those together, all right? This works the same if this was a difference. So if it was A times B minus C, it would be AB minus AC, okay? So that's the distributive law. So let's just do a quick warm up. True or false, everyone, tell me in the chat box. Does 2 times x plus 4 equal 2x plus 4? True or false? I'll give everyone just a moment to answer. Great. So everyone has given me a resounding F, false, and that is correct. So that would not be a correct use of the distributive law. So with the distributive law, okay, these are not equal, all right? Actually, you're multiplying x by 2 and also the 4 by 2. So both numbers in the sum are being multiplied by that number out the front too. So the distributive law, when we talk about, expanding these brackets, so sometimes you'll hear that word expanding, other times you'll hear distribute. So you're distributing that 2 across both terms in the sum. Okay, what about this one? M times n times m plus n. Does it equal m times n times m plus m times n times n? True or false? So just giving everyone a moment to answer. Correct. And Eliza has also said it also needs to be further simplified. That's true. So that's the point I was about to make. So yes, it is true. However, it has not been simplified. So it's been expanded, but we can see that there are these variables, m and n, that can be brought together. Okay, so Ray, yes, you've just actually given me the answer in the chat box. That's great. So in that first term, m times m is m squared. So m squared n, and then I'm adding, called n times n is n squared. So then I have mn squared. Bit of a mouthful when you're trying to say m's and n's and making it so they don't sound the same. You've got to be really careful with that. But when it comes to writing it, a bit easier. Okay, so yes, this was true, okay, but it still needed to be simplified in one more step. Great. Now, today we're going to start talking about binomial expansion, okay? So what happens in a case like this? So I should tell you first what the word binomial actually means. Binomial is an algebraic expression, and it's the sum or difference of 2 terms, okay? So these letters A, B, C, and D, these are known as algebraic terms, okay? They are letters in algebra. So a single term, A, B, C, D, if we look at the sum of A and B, that is a binomial. The difference of C and D is also a binomial. So when we talk about binomial expansion, it is expanding so that we get rid of the brackets, and it's just like in the distributive law. So how can we multiply through? So yeah, Yusuf, that's correct actually. And I'm going to show you how to prove that result now. Okay. So with binomial expansion, it's a bit easier just to work with the sums at the beginning, and I'll show you what you do when you have a sum and a difference, or 2 differences, for example. So with these two sums, A and B multiplied by C and D, where A, B, C, and D are these algebraic terms. And so AB is a binomial, and then C plus D is a binomial. And so we want to expand through the brackets. So I can see some people are writing the answer, Ray, Aaron, yep, that's correct. So I'm going to show you why that's correct, okay? So if you let X equal the first binomial, A plus B. Eliza, that's correct. You can use the FOIL method, and I will show that in a moment. But just to prove why the FOIL method works, okay? If I let X equal A plus B, that means the product of these binomials I can write as X times the other binomial, C plus D. So all I'm doing is I'm substituting, instead of that binomial A plus B, I'm substituting X instead, okay? So then now using the distributive law that we learned last week, so X times C plus D, okay, I can use the distributive law. I can multiply X by C and then add the multiple of X and D. All right, I haven't put the red lines in like I normally do, but hopefully you're starting to see that now, where you might not need those lines so much. So now I can replace X back with that binomial. So X, remember, was equal to A plus B. So then this expansion has become the sum A plus B times C plus the sum of A plus B times D. Now, all I'm doing in the next step is just swapping that order of the multiplication. Okay, you don't have to do that. That's an optional step. Okay, but then now what I'm going to do is use the distributive law twice. Okay, so then C times A makes the AC, C times B makes the BC, D times A makes the AD, and then B times D, D times B makes the BD. Okay, so then I've just proven how to do the binomial expansion. So if I look at two binomials multiplied together, okay, it is doing the following. And yes, that's correct, Eliza, what you mentioned before. Now I'm going to show you the FOIL method, okay? So the first numbers, that's the F in FOIL. So A times C. And I can see that below. The O is the outer numbers, so that's A and D. So then that brings in the second term, AD, okay? The I in FOIL is inner numbers, so that's B and C. So then that's the third term. And then the L in FOIL is the last numbers, so that's B and D. So then they multiply together to make the last term. So you don't need to do all that distributive law work that I did before. Once you learn FOIL's method, it's very quick to just now do this binomial expansion, okay? First, outer, inner, last. Yes, FOIL. Yes, so Ray just spelled out what FOIL is. So I actually forgot that was called the FOIL method, so I didn't put it on the slides. But yeah, it is called the FOIL method. So yeah, first, outer, inner, last. And so I'm about to do that again, except now with this binomial expression, where I've got a sum as my first binomial and then a difference as my second binomial, and I'm multiplying them together. So finding the product of these binomials. So I can do the FOIL method. The first numbers, A and C. The outer numbers, A and D. The inner numbers, B and C. And the last numbers, B and D. And so that becomes this. So I'm adding all of these products together, but notice A is multiplied by negative D and B is multiplying negative D. So the outer numbers multiplied and those last numbers multiplied, so that's the O and L from FOIL, I've got this product of a positive and negative number. And so remember, when you multiply a positive number with a negative number, it creates a negative number, okay? So A times negative D becomes negative AD. B times negative D becomes negative BD. So Aaron, yep, you got that correct. You wrote that before it came up on the slides. Well done. So this then is that binomial expansion for when you have a sum and a difference being multiplied together. Okay. And so you'll expect to see more negatives as well if you were doing two negatives. And we'll have a look at an example of that in a moment. Actually, yeah, let's do some examples now. So I'm going to now move across to Mathspace and start working on some problems. Okay. No, I'm not ready for that one yet. This is an equation which we're doing later. Hold on a second. That should be all the way at the end here. Yes, okay. So what we're going to do here, thank you, Aaron, for solving that. We'll look at those linear equations later. That's the next topic, okay? This is actually another way to visualize binomial expansion using the area of rectangles, okay? So I didn't put that in my slides, but I wanted to work through this question, okay? So the area of this figure, okay, you can calculate by y plus 7 times y plus 8. It can be the product of binomials, right? So looking at the sum of these two measurements, y and 7, and then looking at the sum of these two measurements, y and 8, okay? And so we want to find an expression for the area by finding the sum of the 4 rectangles. So these 4 rectangles. So I can see one student's already expanded. Yusuf, well done. And Aaron has correctly given the answer to part A. Very good, guys. So the area of rectangle A, we're just looking at this rectangle, okay? And so I know there is a length of y and a width of y. So actually this rectangle is that special type of rectangle known as a square, okay? Where we've got these parallel side lengths and they're all equal to one another. So what's the area of a square? Aaron got it right before. How would I answer this, everyone? I'll just give everyone a couple more moments. Yeah, that's correct. I'm getting some other people answering now. It is y times y. Okay, and of course, using indices, that becomes y squared. Okay, so that's the first rectangle. So I know this might be a bit slow for some of you who have already got the answer. Okay, but some of you actually I saw got the wrong answer before. So as we work through this, you might figure out why your fully expanded expression was incorrect. Okay, so now we're looking at rectangle B. So rectangle B, it's not a square. I can see the side lengths are different. We're looking at a length of y and that width of 7. So the area of rectangle B, excellent work, guys. Ray, Aaron, Yusuf, Casey, you've all answered this for me already. It is 7 times y. And then, of course, in algebra, you just bring those together. You don't need the multiplication symbol, which I can see a lot of you did in the chat box already. It's just 7y. Okay. So I'll go a little faster here because I can see some people are ready to answer the final question, right? So yes, rectangle C, okay, we now have that length of 8 and that width of y. So the area is just going to be 8 times y. Very good. Arnold, Remy, Yusuf, Ray, Aaron. So yeah, I can just bring those together, 8y. And now finally, rectangle D, I can find an exact value. So I can evaluate this area because I have a length of 8 and a width of 7. Yeah, so I can see some of you are answering this already. 8 times 7, that is 56, correct. So now if I want to find the area of the whole shape now, okay, this whole rectangle, without doing any of my binomial expansion, to find the area of the whole rectangle, all I'm required to do is add these 4 rectangles together. So the sum of these 4 areas is going to give me the area of the whole rectangle. right? So that's going to be y squared plus 7y plus, I'm not writing. Oh, no, I am. I'm not writing the chat. That's supposed to be here. Plus 8y plus 56. I think I saw some people give some different responses earlier. Yeah, no, a lot of people have got it right. Yeah, someone wrote 2y at the start, but then that should have been y squared. I think someone else added 15 at the end, but it should have been 56. So yeah, just being mindful of some of those mistakes, right? So those two terms, 7y and 8y, are known as like terms. So they add together. So I can write that as 15y, and now that is the final answer. So remember, y squared, a multiple of y, and a constant, when you add them together, none of them are like terms, so you can't simplify any further, okay? The only terms we were able to add together were the 7y and the 8y. So now, as we go on, we don't have to use rectangles and we don't have to use that work I did on the slides. Okay, from now on, when I look at a question like this, I can use that FOILs method, right? So I can do the first numbers multiplied together, the outer numbers multiplied together, the inner numbers multiplied together, and the last numbers multiplied together. So that automatically gives me y times y plus 8 times y plus 7 times y plus 56. And then of course, those y terms are going to multiply. Y times y is y squared. I can collect the like terms, 8y and 7y, to make 15y. And then I've got 56 at the end. So from now on, we can just use the FOILs method to do binomial expansion. Okay. So going to the next problem. I'm going to give everyone about a minute to expand and simplify the following. Okay, so I'll just open up the chat box because I seem to have accidentally closed it, and I'll give you all a moment to answer this question. Yep, Ray, that's correct. Good. Yep, Yusuf, correct. Aaron, I think you made a typo there, but yes, I can see that you're most likely correct. Eliza, yes, correct. Remy, correct. Aaron, yep, you fixed the typo. Good, yep, that's correct. Great. Good. Excellent. Good work, everyone. I will very quickly go over it anyway, just in case there's anyone who doesn't know what to do. Okay, so with the x plus 3 times x plus 5, we are using FOILs method to expand. Okay, so this is the first numbers. I'll actually label it as F this time. Here's the outer numbers. So I'll label that as O. Here are the inner numbers multiplied together. So that's I, the inner numbers. And then here are these outer numbers, 3 and 5, to make L, the last numbers. Okay. So when we find each of those products, we then add them together. So x times x plus 5 times x plus 3 times x plus 3 times 5. Okay, so then x times x is x squared, 5x plus 3x is 8x, 3 times 5 is 15. So yes, well done to everyone who got that on their own. Well done. Okay, so now we're going to go to the next problem. I won't bother to submit that into Mathspace. We all know that's correct. Okay, now we're going to do the product of two differences. So both of these binomials are differences. So we're going to have to be careful of the negatives. Okay, so I'm now again going to give everyone 30 seconds to a minute to answer this question. And I want you to write your answer in the chat box. Okay. So I'll give everyone a moment. So you have to use the FOILs method. Correct. Ray, yes. Yusuf, that's correct as well. Yep, there's a few others I know in the class who are answering my questions. So, Eliza, that's correct. Good. Aaron, that's correct. You just need to collect the like terms at the end and then you'll be correct. That's right. Yep, very good. Very good. Okay. I'm going to start working on the problem now. So using FOIL's method, okay. The FOIL method, it's not a person. Okay, I'm doing those first numbers, x times x. There's that -6 and -4. Oops, no, we don't usually do it in that order, do we? All right, now I don't want to confuse anyone. You know what I mean, most of you, but so we want to do the outer numbers, x and -4, -6 and x, -6 and -4. So let's write that now. I'll write that here. So I'm doing x times x, I'll use brackets, plus x times -4 plus -6 times x plus -6 times -4. Okay, that's how you would technically use the binomial expansion to write this step. So the x times x becomes x squared. The x times -4, remember a negative number times a positive number becomes negative. So I would write that as -4x. Adding -6 times x is the same as subtracting 6x. And now -6 times -4 actually becomes +24. So you're adding 24, okay? So yeah, I believe there were some people that were doing 6 and -4 or x and -x or something. I would just be careful of that. When you do the work, like I've showed you using the FOIL's method, you should be able to place those negatives and positives in the correct place, okay? So -4x minus 6x, collecting those like terms, -10x. So then the expression becomes x squared minus 10x plus 24, okay? All right, let's look at something harder. Let's look at this one. We've got 2w plus 5 times 7w plus 3. So again, I'm going to give you all a moment to answer this. Yeah. Yusuf, I think there's some characters missing there. Ray, yes, that's correct. Who else? Yeah, there you go, Yusuf. Yep, now you've got that plus symbol there, correct. Eliza, yep, that's correct. Yep, good. All right, cool. So there were 1 or 2 people who made a mistake, so I will go through this. All right, so 2w plus 5 times 7w plus 3. We're using the FOIL method again. Okay, so it becomes, we're multiplying 2w by 7w, adding 2w times 3, then adding 5 times 7w, and then adding 5 times 3. Okay, so the 2w and the 7w, remember that's the same as 2 times 7 times w times w. So I think some of you wrote just 14w, but it should have been 14w squared, okay? The next one, 2w times 3, I'm just multiplying that 2 by 3 to be 6. Same for the next product, 5 times 7 is just 35, and then 5 times 3 is 15. So then you just collect those like terms, so it's just adding 35w and 6w, so it becomes 41w. So again, you should have those 3 terms. The squared term, the w term, and the constant. Constant being a number with no algebra letter next to it. Okay. Great. Okay, just having a quick look at the Q&A. Someone has asked me, how am I able to send my answers to you? So everyone's using the chat box. So that should be available for you. If it's not, it might be because you're using Zoom in a browser. If that's or maybe you're looking at your iPad. I'm pretty sure the iPad app does have the chat box anyway. But yeah, it's a bit easier to find when you're on a computer, like a laptop. But yeah, if you're on an iPad, you might have to play around and look for the chat box. So yeah, everyone is, like, yeah, a few of the guys are saying that the iPad does have the chat box. Thank you. I'm not an iPad user, so I appreciate the feedback. So yeah, you just have to explore for the toolbar, find the chat, open it up, and then you'll be able to write the answers to me. Yeah, and so I've currently got it set that everyone can only write to me, so not everyone else in the class sees your answers, okay? It's just like you're privately telling me. So it doesn't matter if you get it right or wrong, no one else here will know whether you got it right or wrong, okay? So yeah, please feel free to participate. Okay, all right, let's get back to work. I just saw that popping up, so I just wanted to deal with that as it came. Here we go. Here's something a little trickier because there's a lot of negatives in there, okay? So we're looking at, I should double check the time. Yeah, we're right. We're looking at, 10y minus 8 times negative 2y minus 9, okay? So while you're coming up with the answer, I will tell you the 2 ways you could do this, okay? One way is to use Foyle's method as is, okay? So I could do those first numbers, the outer numbers, the inner numbers, and the last numbers, okay? Yes, Aaron, that is correct. Yusuf, yes, that is correct. Yeah. So far only Yusuf and Aaron have got that right so far. Yes, Aaron, that's correct once you simplify. Yep. I can confirm that your work is correct, Remy. Good. So keep going. You can get the answer now. You've done that all correctly, that expansion. Just to give you a tip, what you can do, actually, if I look at negative 2y minus 9, we're going to talk more about factorization next week, but you could factor out the negative and just have this as 2y plus 9, okay? So this is a factorization where if you expand, you multiply both these by negative, then it becomes negative 2y minus 9, right? So one way you could do this if you don't like working with negatives so much is that you could write this as negative 10y minus 8, and then you're multiplying this by negative 1 times 2y plus 9. So then with this negative, I could take it out the front, and then this is negative times 10y minus 8 times 2y plus 9. Then you could do the binomial expansion and then multiply through the negatives at the end, okay? So if I do it that way, so this is a different way of answering the problem, okay? You're still welcome to do it the first way. You don't have to do this. This is just optional, okay? So I can do negative times 10y minus 8 times 2y plus 9. So I have factored out a -1 from the second binomial and just put it at the front. So then in the brackets, when I do the binomial expansion, it would be 20y squared plus 90y minus 16y minus 72. Now I can distribute that negative, okay? So I can multiply all the terms by negative. So positive 20y squared becomes negative 20y squared. Positive 90y becomes negative 90y. Negative 16y becomes plus 16y. And then negative 72 becomes plus 72. And so that's what you should have got if you did the expansion correctly without taking the negative at the front. And then yes, you can collect these terms together to get negative 74y. And then that's complete. Yeah. So some people, I think, did negative 90 and then they subtracted 16 to get negative 106y. That's incorrect, okay? When you have a negative 90y, so just a quick little bit of revision on negative numbers, okay? All right, if you have negative 90 and then you add 16, okay, you're moving closer to 0, okay? So you're going this way by 16 units. Okay, so that would actually take you to 74, negative 74. All right, so do be careful when you're adding and subtracting negative numbers together. Okay. All right, we're almost done with binomial expansion, everyone. Yeah, this is something, it's a bit of trickier. Okay, it's like working backwards. Okay, we want to fill in the blanks to make the following expression true. Okay. And this will really help us as we understand factorization next week. All right? We're not going to do factorization this week, next week. So what would be the blank? What would I need to write in there in order for this expression to be correct? Aaron, you have got the answer right. Very good. So something has to be in this bracket such that the answer is t squared minus 14t plus 45. Ray, no, Yusuf is correct. Aaron is correct. Aaron, that is a correct way to do it, right? So, yes, Ray, that's right. Yeah, good. Okay, so I want to multiply those first numbers, okay, to create this number. And then I know -5 will multiply by a constant to create this number. Okay, so it's focusing on those first and last numbers first. Okay, Yusuf, yes, you are correct. It's focusing on these numbers first, right? So t times what is t squared? So the answer is t. Very good, Remy, Ray, Aaron, great. So yes, that missing number I can see is t. So t times t makes t squared. So this could be a t as that first number, right? Now for the other one, all right, I have -5 times what is going to give me positive 45. Correct, Remy, Yusuf, Eliza, Casey, Ray. Very good. The answer is, remember, -9. Okay, some students might say 9, but 2 negatives multiply to make a positive. Okay, so then this could be the answer, t minus 9, but let's test that because we still want this to work so that the like terms collect to make -14t. Okay, so let's test that now. So t minus 5 multiplied by t minus 9, when I use FOIL's method, I know the first and last numbers. I've chosen this so it's going to become t squared and plus 45. But now when I do the outer and the inner multiplications, I get negative 9t and negative 5t. And yes, oops, 5, not 14. And yes, these do collect to create negative 14t. Excellent work. So yes, that is what we fill in the box, okay? So it's t minus 9. Okay, so that's all we're going to do about binomial expansion. Okay, now we're going to move on to the next topic, which is solving linear equations. Okay, so the thing about solving linear equations is this is pretty much revision. Okay, you've been doing this already for all year 7 and 8, right? And you might have even done some work in grade 6 too. Okay, so here we go. Yeah. So just a bit of revision. Okay. So when we're solving linear equations, it's all about balancing the equation. Okay. So that the man from Uzbekistan that we were talking about last week, Al-Khwarizmi, yeah, he came up with that book of balancing and restoring. Okay. And that's where that word algebra comes from. So now we're going to be doing this balancing and restoring to solve for x, okay? So yeah, no, we're not doing linear equations yet. So yeah, there is a confusion here. Yes, Ray. So sometimes when we talk about linear equations, we're talking about the graphs. So y equals mx plus c. That's something we will do later in the term, okay? When we talk about solving a linear equation, it's actually just solving for x like this. So this is an example of a linear equation because there's no powers, it's just x and numbers. So these operations that we're looking at are, you know, addition, subtraction, multiplication, and division, okay? So some people are writing the answer already, which is great because this one is a very easy one, okay? So I just wanted to show you when we're balancing the equation, when we're making x the subject of the equation. So that's what we're doing. We're trying to solve for x. This one's particularly easy. You could just do it in your head. You don't need to do any algebra because you know 6 plus 5 is 11, right? But when we talk about that inverse operation, so with the x, you add 5. So what would be the inverse of adding 5? Can people write that for me in the chat box? Remy, correct, subtraction, but what is it that you're subtracting? What's the opposite of adding 5? Ray, Aaron, Eliza, this is all correct. Yes, correct, Remy. Yeah, so you're subtracting 5 from both sides of the equation, okay? And so the reason is when we subtract 5 from both sides of the equation, you've got that plus 5 and then minus 5 on the left-hand side, which will just cancel, right? Because 5 minus 5 is 0. And now you've just got x on its own on the left-hand side. Yep. But remember, the key thing with solving linear equations, what you do to one side of the equation, you must do to the other. So that's why we subtract the 5 from 11. It's all about, exactly, Aaron, correct, balancing and restoring. Yeah, Eliza, good. Yes, you have to balance both sides. So x in this case is 6. That's right. Okay. Now, I haven't really prepared much in the way of other slides because you've done all this already. You've done it in year 7 and 8. Now we're just going to practice until the end of the session. So we've still got about another 5-10 minutes, okay? And then we'll do some Q&A. All right, I'm just going to now work through some problems with you. All right. Should not be alt-tabbing. I'm already here. Yeah. Okay, great. So here we go. This is a real basic linear equation to start with. 6 times j is equal to negative 54. So what would be my answer? Or you could tell me the first operation, up to you. Okay, you might not, if you don't know the answer, you might want to try tell me what you have to do to both sides of the equation. Aaron, yep, Ray, Yusuf, these are correct. Remy, the answer is technically you don't use X. So we shouldn't see the letter X in our solutions, everyone, because we're not working with X now. We're working with letter J, okay? Now, I want to talk to you because now we know what we're doing, right? I just want to now talk to you about giving tidy work, okay? When you're working in your workbooks or, you know, when you're maybe answering an assignment that your teacher's given you, okay? In year 7, it's all right if you just write -9 as the answer, okay? So in your book, you might have the equation and you just write -9 and then you keep going, all right? If I press enter in Mathspace, it actually tells me there's an input error, okay? But that's because I'm not answering the question technically. I'm supposed to be solving for J, okay? So let me show you how I would write this in my book if I were a student, okay? So with 6 times J is equal to -54, okay? You want to use an arrow to then talk about what the equation becomes, okay? So I can divide both sides by +6. And so that's going to cancel the 6's, okay? And I'll just have J on its own. So now in the next line of work, J is equal to, well, -54/6, that is correct, -9, okay? I could work out 54/6 is 9, and then I keep that negative out the front. So note that my final answer is an equation still. I have answered the problem that J, it is what's equal to -9. So I would recommend this is the way that you show your work, okay? You go down the page, all right? So let's work on another problem. This one's an interesting one, okay? So 72 divided by Q times -12, all right? Don't tell me the answer yet. If you know what the answer is, don't tell me, okay? What would you do to try and balance this equation? What would you do to try and make Q the subject? So you can write to me, you know, in a sentence or, you know, in the chat. What would you do to get Q on its own? Because currently it's in the denominator of a fraction. So yeah, asking everyone a question, and please write the answer in the chat box. This one's a bit tricky. Some people are talking about multiplying 72. Some people are talking about dividing by 72 or dividing by 12. It's a bit tricky, this one. Yeah, Casey, that's the answer. Yeah. Okay. Yeah, Ray, that's correct. So yeah, Ray's giving me the correct description. Okay. I think everyone knows what the answer is, but maybe they're a bit like, well, how do I get Q on its own? Or, you know, how would I describe to get Q on its own? Maybe you know how to get Q on its own, but you don't know how to explain it in words, okay? So with 72, let's try again. 72 over Q is equal to -12. What I can do is I could multiply both sides by Q first, okay? So multiplying both sides by Q, right? You are dividing, that is the inverse of dividing by Q. So the inverse of dividing by Q is multiplying by Q. So that cancels it out on the left-hand side, but now it's sitting in the correct position on the right-hand side. So I can write this now as -12 times Q is equal to 72. That's correct, okay? And so now from there, you probably know what to do, right? It's similar to before. You divide both sides by -12, right? So Q is going to equal 72 divided by -12. And the answer is -6. Okay, so you can do it in 2 steps like that. I'll show you another way that students don't typically use, which I like. Okay, so 72 over Q is equal to -12. Does anyone know how I'd write -12 as a fraction? Can anyone tell me a fraction that is equal to -12? Yusuf, correct. Aaron, correct. Ray, correct. Good guys, yeah. So if you just divide it by 1, yeah, Chetna, correct. If you divide by 1, it's a fraction. 12 over 1 is 12, right? -12 over 1 is -12. So the reason why I do this is you can, if you have a fraction on one side and a fraction on the other, okay, as long as it's the one single fraction, okay, you can take the reciprocal of both sides. So then that means Q over 72 is equal to 1 over -12, or you could write this as -112. So then all you have to do is multiply both sides by 72. So then Q, because the inverse of dividing by 72 is multiplying by 72, you can work out as -72 over 12. So that's another way to do this. Like, you have to be really careful with taking the reciprocal of both sides because it has to be a fraction, right? If you've got x over 3 plus half equals, 5/6, for example, what I'm about to do is not allowed. You can't do this. You can't take the reciprocal of these two and then the reciprocal of these two. It is incorrect to do, 3 over x plus 2 over 1 equals 6/5, okay? That's not correct. You can't do that, okay? What you have to do if you're going to take a reciprocal is that this has to become the one fraction. So you've got to find the common denominators and then add them together, okay? Now, of course, in that specific example, you wouldn't do that. You don't want the x to go into the denominator. You want it to stay in the numerator, okay? Yeah, okay. I just wanted to make that point. But that's another trick that you could use. All righty, we've still got a little bit of time. So I want to talk about this question, okay? See, because there's actually 2 different ways you can do it, all right? Tell me in the chat box, what is the first operation you would do? So what was the first step? Great. Interesting. Good. Yeah. Yusuf, Eliza, Ray, a few others, I believe, have talked about, I think Eliza and Aaron have talked about expanding. So using that distributive law to expand. So you can get -7n, and then -7 times +1 is -7 is equal to -56. And then you go ahead and solve this. But then Aaron and someone else, no, I think just Aaron so far has talked about another way to solve this equation, okay? So the other way is just simply dividing by -7. So watch what happens when I divide by -7, because that's the inverse of multiplying by 7. So these now cancel, and I'm just left with n plus 1. So n plus 1 equals -56 over -7, +8. Okay, and then yeah, that's right, Ray. N is then just 7. So that's 2 different ways you can do it. It doesn't matter which way you do it. Whatever you like, okay? As you start to learn more and more about algebra, you'll find that, one student will solve an equation and then a different student will use a different way to solve the equation, right? It's just whatever you prefer now, okay? So you know now how to distribute, you know how to expand brackets, so you could use that way as a way to solve the equation. Or if you can, you divide, right? See, the thing is, if this was, let's look at a harder, let's change the number here. If this was -7 times n plus 1 is equal to 50, okay? Well, 50 divided by -7, it creates a fraction, an improper fraction, right? You can't then, you know, do it. So you could then expand. That might be better in this case. What you're going to find is you'll still get probably an improper fraction as an answer, but just the working, the calculations that you do will just be easier if you expand in this specific case, right? So if I went -7n minus 7 equals 50, so then -7n is going to be 57. So then you get your answer, n is -57 over 7. And you can't simplify that. That would be the answer, right? But then it's just that you could still use this way if you wanted to, but then you would just have to be adding and subtracting a fraction to an integer, and it just adds a little more complexity to the problem, okay? So that's why we like to teach you all these different ways to answer questions so that when you are solving the questions, you've got multiple techniques you can use. Okay, we're getting to the end. Let me just pick one more question to do. Not that one. Yeah, let's do this one. Yeah, thanks, Arnold. I know it's 10:58. I've got 2 more minutes. So very quickly then, let's work on this question. It doesn't have any brackets, but it is a trickier one. So the question actually tells you how to do it. It's to do it by cross multiplying and then expanding brackets. Okay, so I'll answer the question now, but yeah, if you want to try give me the answer in the notes, go ahead in the chat box, go for it. Okay, so with 4x plus 8 over 8, okay, equals -3x plus 12 all over 3. One way to do this is to multiply the left-hand side by 8. And remember what you do to the right-hand side, you do to the left. And then you multiply the right-hand side by 3. And so then what you do to the right, you do to the left, okay? So then these 8s will cancel on the left-hand side, these 3s will cancel on the right-hand side. So then this becomes 3 times 4x plus 8 equals 8 times -3x plus 12. So then you could go ahead and use the distributive law and then combine all the like terms together and then transpose, and you can solve for x that way. All right. I'm going to show you an advanced way to do this question. Okay. 4x plus 8 over 8 equals -3x plus 12 over 3, okay? What we're going to learn next week is factorization. So 4x plus 8, I could take out a factor of 4 out the front. With -3x plus 12, I can take -3 out the front. Okay, if you don't know how to do this, that's okay. I'm going to go through it next week on how to factorize expressions using the distributive law. So it's going in reverse. So an advanced way to do this is I could do 4 divided by 8 and 3 divided by 3. So then this becomes x plus 2 all over 2 when I simplify that fraction on the left, and then negative times x minus 4 now that I've got rid of that 3 from the top and bottom. So then I could multiply the 2 across. So then x plus 2 is -2 times x minus 4. And then I can expand the right-hand side. So that would be -2x plus 8. Watch the negatives. Don't forget the 4, right? And then you can keep working and solve for x. So I get 3x plus 2 equals 8. When I add 2x to both sides of the equation, I'm rushing through this because we've got to finish. You know, subtract 2 from both sides, 3x equals 6. And so the answer is going to be x equals 2. Okay. So yes, good work for some of you who answered that in the chat box. I can see you got x is equal to 2. Very good. Nicely done. But I just wanted to show you a different way you could have approached that question. However, I technically wasn't following the question's instructions. I was supposed to cross multiply first, then expand the brackets, okay? But I just wanted to show you a bit of a preview about what we're going to be doing next week with factorizing. Factorizing by what's called a highest common factor. And then we'll even look at factorizing binomial expressions, which is a bit trickier. We haven't seen that today yet. Okay. All right. That's it, everyone. Let me check if there's any Q&A. I can stick around for another minute or two if there are any questions. Oh, that's creepy. Are you going to give us homework? I was supposed to bring a puzzle, wasn't I? Sorry, I didn't know. I won't be giving you any homework today, Eliza. I've got to get going. But next week, I promise, I'll give a harder question for you to take home or, take with you, and then you can give me the answer next week. Yeah. A couple of questions. How many of us are there? Yusuf has asked me. Today, looks like there was 12 students and then me as the teacher, so a total of 13. So not many today. We've had a little bit of a drop off. I'm hoping now all the states around Australia have now finished their school holidays. I'm hoping in the future weeks we'll have more people come. But it's great that you've all been able to come. And also if you're watching the recording at home, thanks for watching the recording. It's great to have you here. So yeah, I've answered Eliza's question. No homework for this week, but next week I'll come with a puzzle. I've answered Yusuf's question. Great. Yes, Micah, correct. I was going to do a hard question at the start and then answer it at the end. Yeah, I completely forgot. I'm sorry. Let's we'll do that next week. Okay. I'll bring a hard problem at the start of the class and I'll make it a really hard like linear equation with expanding or something. And then at the end of the class, someone can give me the answer to that problem. All right. And yeah, and then at the end of the class, maybe I'll give you another hard problem to take away and then bring back next week. Those are really good ideas, guys. Let's do that because I think some of you could use the challenge and that's great. Otherwise, completely optional. You don't have to do hard questions if you don't want to. If you're just here to learn and revise, that's fine. Okay. Getting some thank yous in the Q&A. My pleasure, everyone. Thanks for coming. Let's finish up. And thank yous from the chat as well. Thank you all. Hope to see you guys next week. Yeah, and tell your friends if they're in Year 9 or even if they're not in Year 9 and they want to do some Year 9 work, come along. All right. Thanks very much, everyone. I'm going to finish up and I will see you same time next week, 10 a.m. Thursday. See you later.